So we got first on our panel, Benari, the CEO of NuoDB. He's got 25 plus years of leading technology companies ranging in size from startups to over 1,000 employees. He was formerly the CEO of IONA Technologies, which is Ireland's most successful software company with 10,000 plus customers and $180 million in revenue. He co-founded NuoDB with Jim Starkey, who, as we heard in their trivia, is the creator of the BLOB datatype, as well as MySQL Falcon storage engine. Start with a round of applause. Next chair over, we have Bob Wiederhold, President and CEO of Couchbase. He's got 25 plus years of experience. He was formerly the what? They're giving away something?
We're all 25 plus years.
Yeah. He was formerly the CEO of Transit Corporation, which was a virtualization company with 20 million users, and eventually was acquired by IBM. He was also formerly the CEO of Tality Corporation, an electronic design services company that he grew to nearly $200 million and 1,500 employees. Please welcome Bob Wiederhold. And in the final seat to the left, we have Eliot Horowitz, CTO and co-founder of 10gen, the MongoDB company. He is officially the core MongoDB kernel committer, which is a very fancy way of saying he wrote a good chunk of MongoDB. So that's quite impressive right there. He was formerly the co-founder and chief scientist of ShopWiki, which was acquired by Oversea.net. And he co-founded 10gen with Dwight Merriman, who was part of our trivia questions, who was the co-founding CTO of DoubleClick. Please welcome Eliot Horowitz. All right, we're going to start off this presentation with each of our panelists giving us a brief overview in elevator pitch style of the databases that you represent, basically discussing the key differentiating features of each. And please, Barry.
Sure, yeah, so it's possible we're the least well-known of the folks on the stage because we've most recently got to market. But for those of you that don't know NuoDB, the way people tend to describe it to us is it kind of looks like a NoSQL database under the covers, but from the outside, it's pure SQL. It's SQL, it's transactions, it's all the stuff that you know and love in terms of SQL databases, but it has all the scalability and flexibility and schema flexibility and so on that you might be used to in terms of the SQL database. So Couchbase is generally regarded as one of the three leaders in the NoSQL space, along with 10gen with MongoDB and DataStax with Cassandra. We are the clear leader in one of the technology spaces that fit under NoSQL, the key value database space. And recently, this past December, we extended our product to be a document database as well. So we're now direct competitors with 10gen and MongoDB. So we'll see how that works out today. We're part, I think, together, NoSQL is growing very, very quickly, and we think provides a great alternative to relational databases for the kinds of applications that are being developed today, particularly web and web-based and mobile-based applications, and growing very, very fast.
Right. So MongoDB, the way I think about MongoDB these days is we took what, if you look at like a major relational database, whether it's Postgres, MySQL, or Oracle, and we said, all right, what are we struggling with? And the two things we really struggled with were scalability and flexibility in schema design. And so what we found was that by going to a document model, we actually can solve the scalability problem and also make it a more fundamentally easier database to work with from a developer standpoint. And once you have that, the idea is a document database that's scalable with a lot of concepts that are pretty similar to relational databases. Like indexing, a lot of those things work the same way MongoDB is doing a relational database. And we try very hard to keep a lot of the technology from relational databases similar, those with a different data model and scalability.
Oh, you kind of actually answered the follow-up question, so you'll be the first answer in reverse order this time. What were the principles of innovation that drove your product development? Kind of start to answer that.
Right, so really what it came down to is when we looked at what we struggled with developing products and very scaled products for the decade before we started MongoDB, it came down to one is inflexibility with schema, right? So if you think about things like ShopWiki where it's a catalog and you've got to do a lot of take a lot of the things that require transactions and by putting them in a single document, you can actually do a lot of very nice things without multi-document transactions, and then you get the scalability much simpler than you were trying to do in a relational model.
So we came at NoSQL a little bit differently. The company actually started by focusing on Memcached. And Memcached was starting to, not starting, it was already starting to proliferate very, very widely. And that was a great, obviously a great caching technology. But increasingly, we found that people were using Memcached together with MySQL. But for scalability and performance reasons, they were really using MySQL just as a key value database. And so the first opportunity that we saw was to, in essence, do layer consolidation, to consolidate and provide a managed caching layer together with persistent storage, which is a key value database. And we really focused on very, very easy scalability, very reliable scalability, and very high performance. Performance both from a latency perspective, low latency, and from a throughput perspective. And that's what we really became well known for, was that very easy, very reliable scalability, very high performance. And it was always our strategy to then evolve and extend the product to be a document database. And for some of the reasons that Eliot mentioned, is that people that are using MySQL or some other relational database, they want to be able to build indexes and do querying and things like that, and have the database handle that. And so we extended the database, partly through the merger with the company behind CouchDB, which is Couch One, and extend the database to be a document database and do all the indexing and querying that developers love. So that's kind of the evolution of our product.
Great. So Jim had been working, this is Jim Starkey, had been working at MySQL actually to build what would have been the replacement for InnoDB. You recall that InnoDB and MySQL kind of went in two different directions. Oracle had bought InnoDB. And there was this plan to replace it with something which became known as Falcon. And Jim was the architect behind that. And he'd been working on that, and he kind of got to the conclusion, we're solving the wrong problem. The problem with databases, which I think we're all familiar with, but to just quickly say, the problem with databases from the 1980s is that they're essentially scale-up architectures. And Jim's view was, and I think this was one of the brilliant insights, that it's nothing to do with SQL or NoSQL, it's nothing to do with whether it's documents or anything else. It's to do with the underlying model, the underlying transactional model of these systems that has always been the same. In effect, has always been basically a file system. So databases are kind of grown-up file systems that allow concurrent access and all sorts of good things like that. But you have to get away from that in this new world of scale-out architectures and so forth. And so Jim's brilliant insight was to say, is there a way to build a genuinely peer-to-peer system? Basically a system of distributed objects, all peers of each other, that are messaging to each other at very high speed, that provides transactional persistence, irrespective of whether it's SQL or not SQL or anything else. And so the system is something which we talk about, it's based on this thing that we call emergence. And emergence is what you see kind of with a flock of birds or with a school of fish, where there's intelligent behavior in the group, but no one's in charge. Okay, there's completely distributed control. And you can shoot as many birds as you like in the flock of birds, it keeps flying, because no one's in charge, right? And can you build, and again, forget the superstructures, can you build an infrastructure that can do that, so that you can just keep adding machines and it goes faster, or it has more data capacity than that? And so the short version is, if you look at our system, the design of it is a layer that really doesn't know anything about tables or rows or indexes or anything else. That's where the patent is, that's where the magic is. It's layered on top of key value stores. Today it doesn't support CouchDB, but it could. And frankly, it could support CouchDB on one machine, and it could support Amazon S3 on another machine, or a file system on a third machine at the same time. So the storage architecture for this database is really quite separated from the real database, which is running as a distributed in-memory system. And layered on top of it, as a go-to-market choice, is SQL. Because it turns out that right at the moment, there's a big piece of this market, by far not the whole piece of the market, but there's a big piece of the market that knows and loves and cares about SQL. And so the short version is, you've got a SQL database that you wanted to go faster, give us more machines. Don't take it down, don't reconfigure it, don't partition anything. And by the way, with it, because it's not fundamentally a SQL database, it's fundamentally a much more general thing, it's got very flexible schemas and all the other things that people actually want in modern systems.
Okay. Bob, you mentioned MySQL briefly, so I'll throw it out there as a curveball. Is there functionality in traditional databases like MySQL that your database can't replicate?
Well, it can't. I mean, certainly doesn't today, and probably there certainly are capabilities that relational databases probably will do better than NoSQL databases in the future. So I think, you know, we certainly don't believe that relational databases are in any sense going away. You know, they represent, you know, maybe 95% of the technology underpinnings of the $35 billion database industry today. And we think it for sure does some things really well. We think with the emergence of you know, web applications and mobile applications, with big data, you know, more data-intensive applications, because these are web and mobile applications, the applications need to support, you know, certainly hundreds of thousands, oftentimes millions, sometimes tens of millions of simultaneous users. If you look at all of those kinds of changes that are taking place, we simply think that NoSQL databases, whether it's from us or from 10gen or from someone else, are better aligned with the scalability requirements, the performance requirements, and the data model requirements that people are looking for. More and more of the data is semi-structured data, it's unstructured data. That kind of data fits much better in schemaless NoSQL databases, I think, than in relational databases. But if you have if you want to do, you know, two-phase transactional commits in a banking application, as an example, today relational databases, that's the classic example of where relational databases are better. And so great, use them for that, right? We're not saying today, or I don't think, you know, in the future that everything is going to go NoSQL. But we do think it's going to go from, you know, relational being 95% of the underpinnings of this huge industry to 50%, 40%, something substantially less 10 to 15 years from now than what it is today, because we think NoSQL is better aligned with the needs of not every application, but an increasing number of applications that are being developed today.
Sure. So I would break down features into a few categories. And let's pick one, for example. One is transactions, and multi-document transactions and multi-row transactions. And so Mongo doesn't have it today, relational databases have it, and that's something people ask us a lot about. You can already add that. And so here's the way we sort of think about it, which is that there are ways you can imagine building multi-document transactions that don't inhibit scalability. For example, let's say you had 10 collections and they're all partitioned on the same key, and you said, you know what, I've got these 10 collections, they're all partitioned on the same key, and for each key range, I want to make sure that those documents live in the same server. And then you can say something, well, then I can do multi-document transactions across those 10 collections on the same partition key, and it's on a single server, which is fast, right? The problem with, you know, getting multiple servers involved is that you go two-phase commit, it's a little more complicated. If you're doing multiple data centers, if you've got, you know, if one document lives in New York, one document lives in London, you know, by design, you're in trouble. But if you can limit the transactions to a slice of the data, then sure, you can do multi-document transactions. And so the way we generally think about things is, look, there's a lot of features people want from relational databases, and we generally are trying to add a lot of them, as long as they don't inhibit scalability or inhibit ease of development. So multi-document transactions with some angles on it, absolutely. But you know, we really just want to make sure that scalability and ease of use are never lost.
Can I just add a little piece? I think this is, you know, even when Eliot said that this is the important thing about NoSQL and relational databases. It's like both sides are going to be able to say, we can do that, right? Like, you know, Facebook is always used as an example of, you know, they use a bazillion, have a bazillion servers running MySQL. You can do it with MySQL. It's just that increasingly you don't want to do it because that is not the best fit for if you need that kind of scalability, right? So I think what Eliot said is completely correct in terms of transactions. The question is, if you really need a great, two-phase transaction capability, and that's the heart of your application, relational might, be the best solution in general for that. But there are many other reasons why NoSQL is going to be much better suited. So we may add some of those features and say that we can do it, and in certain circumstances it may work, but maybe in other circumstances, relational is fundamentally at the core, you're going to be able to handle certain things better.
So, as you'd expect, there's some things that I completely agree with, and some things I would probably consider that there's kind of been advances that perhaps people should take note of in relational technology. So the parts that I agree with are really, first of all, just to note, the question was, are there things that MySQL can do that we can't do? And the answer is no. It's a SQL database, it's transactional, it's fully standards compliant, supports most of the languages you're interested in, and so on. It's a relational database. The part that I probably certainly would take issue with is the idea that just because a particular relational database, namely MySQL or things that have similar architectures, has some limitations, doesn't mean that there's anything inherent about SQL or transactions or any of these other things that you associate with a relational database that make them non-scalable. Okay? Now, the easiest way I could explain how it works, but that would take a very long time. The easiest thing to say is we're running transaction rates which are in the millions and millions of transactions per second on dozens and dozens of machines, scaling out. We haven't found a limit in this system. So if scalability to you means being able to run very large websites at tens of millions of transactions per second, I think we can do that as well as anybody. If the question is, can you scale to very large data sets? Well, the answer is we can run on top of HDFS, for that matter. That's a supported storage model. So if you want to run on top of Hadoop HDFS using our system, you can do that, and that scales to petabytes and so on. So I think that with respect, some of the suggestions about limitations of relational databases is somewhat out of date compared to a new architecture of the sort that we're describing. Having said that, I do agree with the fact that there are different things that you use for different things. And so there are times when you want to use a file system, because that's all you need. And so why use anything other than a file system if you don't have to? And there are going to be times when you really do want to have not just multi-row transactions, but multi-statement transactions. We've got customers that are running thousands of interactions with the database before doing a commit. And they're very complex. And guess what? There's a requirement for that out there. And so, yes, these are requirements that people have to do. And it's very hard to do that in a way that can scale. Last comment, if I can just say it, is on the topic of transactions themselves. I think that people have perhaps misunderstood transactions and the purpose of transactions. There's a view that says you only use them when you really need them. And unfortunately, that's not really the point of transactions. There's actually nothing that you really need, including a database system. So the notion that you really need transactions anywhere is untrue. You use transactions like anything else in computing if you're wanting to improve productivity, improve quality, and reduce costs. And those are the only reasons that you're using a database system at all, by the way. And certainly it's the same thing for transactions. So the point about transactions is you can use much less skilled people to build applications much faster, they will be more reliable, and they're going to be cheaper. That's the reason you need transactions.
Okay, we actually got an audience question up through GoChat on databasemonth.com. Brand Hunt, where are you? Raise your hand, Brand Hunt, right there. Okay, he wants to know what's the largest deployment of each of your respectable databases.
So first of all, we're an operational database, as are NuoDB and MongoDB, and I think our largest is probably 80 nodes, and that's storing. Well, actually, so 100 and OMG Pop, which is a New York company, was actually running. I think it was 123 nodes. And were storing, I think at the time, like 7 terabytes of data. Many of you are probably familiar with Draw Something, and they rose from virtually nothing to 50 million users in like 5 weeks, and so they were able to very, very quickly scale up their database tier. so that's probably the biggest one that we have right now. We have plenty of customers that have, Zynga, for example, is running thousands of nodes of our stuff. But in terms of individual clusters, right, without any application level sharding, right? You hear lots of people talk about, people running 100 nodes, 200 nodes, 1,000 nodes. I doubt they're running that number of nodes without application level sharding, right? So I think you got to be careful. Make sure you ask that question if you're asking, what number of nodes are running in a cluster. Because obviously, as you grow the number of nodes, the complexity in the architecture that you need to be able to support much, much larger numbers of nodes changes quite drastically. And so anyway, that's our answer.
I mean, just to reiterate what I said before, these guys have been out there much longer than we have, and they're doing a fantastic job with these very large systems. We have not got the kinds of huge deployments that you're talking about. I can tell you that the system does scale we've scaled it in our own labs to over 100 nodes quite happily on a single database without sharding and without any kind of manual partitioning or anything of that sort. So it does scale to those kinds of numbers with huge, huge throughput numbers and obviously very, very high both high concurrency and very low latency. That's what it's really good at. In terms of data set sizes, you're talking terabytes, and we're not in the kind of petabyte range today in terms of deployments. But we shipped on January 15th for the first time.
The largest single cluster I know about, we keep hearing of big ones that we don't know about because it's open source. The largest we know about is actually a government cluster that last time we checked was 400 shards, so 1,200 nodes, and about 250 gigs per shard. So 400 times 250 gigs. And I think each node is doing about 20,000 transactions per shard. So, math must not speak. So 400 times 8,000 transactions per second.
A lot.
A lot.
Okay. Next question is, what type of data projects would you consider to be an ideal fit for each of your databases? Start with things, Barry.
Sure, and this is one of the challenges, I think, probably for all of us, as Bob said. These are operational databases. They're fairly general purpose. There are other databases in the landscape of databases that are quite targeted and narrow in what they're trying to do. So these are general purpose databases, and I think you're going to hear from all of us that they're quite broadly applicable. Certainly, in our case, the simple answer would be whatever you're using MySQL or Postgres for, you can use us for. It doesn't necessarily answer the question. We are extraordinarily good at very low latency, very high scale, lots of transactions per second. And very high concurrency. That's what the system is very, very good at. One of those applications, typically they're web-facing, web-scale kinds of applications.
So we have over 400 customers now, and so there's a very broad range of use cases that people use Couchbase for. Social and mobile, gaming, advertising platforms, online business services like Salesforce and Concur, e-commerce, social networking. Now enterprises are starting to use Couchbase much more heavily over the past 6 or 9 months, so big in financial services and communications companies. In terms of the use cases, there's a bunch of use cases that have been very strong for us. One is caching tier replacement, and so that's oftentimes one of the first deployments of Couchbase technology, particularly in big accounts. And there, oftentimes people are using Memcached or maybe Coherence or Terracotta, something like that. And if they're using Memcached, that's elastically scalable, but you have to take your cluster down to be able to, rescale your caching tier. If a node fails, you have to warm up the cache. And so we provide a great solution, kind of a Memcached plus, if you will, and that's a way that a lot of customers get started with us. Then they love the technology, and then they start using it as the database of record. We're really big in global ID stores. So increasingly, we're finding a lot of big global companies. Of course, they have customers around the world. They have a lot of different apps. They want to store a single user profile or user preferences, any information associated with a user. And they need super, super fast access to that information. information and a huge scale. They want to be able to mirror their databases in multiple data centers, so things like cross-data center replication, which we have, I think, a great capability for. That's very important for that. Other things, session stores, whether it's for your games or just session, whenever you're coming to a website, you want to do session stores. So that's really big for us. When you're aggregating a lot of content, there's a lot of travel sites that use us. They get information from lots of different sources and all kinds of different formats. And so, using a JSON model to store that information that's schemaless turns out to be a great fit. And I could go on with more use cases. Those are a few of the bigger ones.
As you're talking, one of the audience members just asked a question exactly what you said about travel sites. Mahbub Alam, are you here? Raise your hand if you are. Someone? There you are. And he just wanted to actually know exactly when you were talking about travel sites, replacing Oracle at Orbis.
Yeah, so Orbis, by the way, if you want a detailed presentation that Orbis gave on their use of our stuff, they would replace Coherence. Sitting in front of Oracle, that was their first step. And they had a lot of reasons to do that. They wanted higher performance. They wanted easier scalability. A big issue for them was downtime. They ended up having a lot of time where they had to do maintenance and downtime. And what they loved about our stuff is, you're always on, we call it, right? You can do all of your hardware maintenance while you're online by just failing out a node and putting in a new node, doing your hardware maintenance, and then joining it back to the cluster. We allow you to be able to do your software upgrades online. So you can run multiple versions of our software in the same cluster and basically use the same approach. Fail out one node at a time, load up the new software, join it into the cluster. So things like, again, the soundbite is always on. Those capabilities are very important to a lot of customers. And so that's the first thing Orbis did. My understanding is that they use us now, I think, for all of their hotel and airline reservations and inquiries. And that's one of many travel sites that uses our stuff.
Okay.
Great. So I actually see a lot of Mongo users here, and each one of them probably with a different use case. So it's going to be pretty hard to actually break them down. But I think generally what you'll see is if you're questions, why does someone migrate from they've got an existing big Oracle system? Why do people migrate? And the answer comes down to one of a few things. One is that the data model is causing them trouble. We had a couple of big users who migrated, and even though it took a long time to migrate, it was because they really, with Mongo, they were able to just develop faster, and they caught up on their product roadmap to move over. Some is for scalability, and one thing you'll see in common is that there are a lot of things where the data model is complex. So think about user profiles where you've got some basic attributes, so you have an array of attributes that you want to search, and you've got sort of complex structures where it's not just a single row. Those things can be a lot easier to model in a document database. So that's general, but it is quite broad. So it encompasses a lot of things. A lot of things, Couchbase is used for, Mongo is used for too as well. So it's very long list. So I will not bore you with listing all of them.
All right, I'm going to throw you guys another curveball to kick up the excitement. Of the other two panelists' database here, what features do you most envy from their databases?
So we already talked about one, right? One is sort of some form of transaction. And I think that's one that I definitely, if you are interested in a slightly different format than a relational database for some technical reasons are pretty important. But I think that is something that there is definitely a use case for it that's pretty important. And I think that is something we will be definitely looking at, adding over the next couple of years.
For us, 10gen and Mongo, as Eliot said earlier, they focused on the document side of things for a long time. They put in a ton of features, broad, deep set of features for the developer. We just got our first document database out in December, and while we think we provide more than enough and very robust indexing and querying capabilities, I think if you did line by line every single feature, you'll have more check marks on the MongoDB side. We have focused much more on scalability and performance, and we think that's where the advantages are. I don't have any envy or for NuoDB. It's not because they don't have a great product. I just feel like they're in a somewhat really different market. think where relational makes sense from our view, that's where you're going to consider NuoDB. I don't know of any accounts where the battle is between NuoDB and Couchbase, right? And it's not just NuoDB, whether it's one of even one of the other NewSQL companies, VoltDB or Clustrix or whoever else. I don't see us competing because at some point relatively early in the process, someone, I think, has decided, okay, for this use case, I need to make a fairly fundamental decision about whether this use case is better aligned with the trade-offs that NoSQL companies have made in terms of the base technology, or this use case maps better with what the relational trade-offs are. And so as a result, we compete more with 10gen and DataStax and others that we see all the time, but not NuoDB. So that's why I don't have envy. It's only from that perspective.
Okay. And I don't know if envy would be the word, but I would say this, and again, maybe this is a slightly different perspective, but what I've seen happening in the industry is actually much more convergence than divergence between these various database systems. And so people that have historically been key value stores are adding document APIs. Relational databases are adding document storage models. That's already in MySQL and Postgres and so on. And so you're seeing that happen, a lot of startups as well, by the way. So you're seeing that there's a convergence of these different models. Again, our view is that the model isn't really the hard part. And I think what you're seeing is that, on the other hand, you're seeing both on the analytics side, where you're seeing, we're seeing that Cloudera are coming out with their sort of SQL on top of Hadoop and so on. You're seeing people putting more and more SQL into systems that historically weren't really SQL systems. So there's a convergence happening, and I would probably disagree with Bob in terms of when this industry it's going to consolidate, by the way. There's far too many vendors out there. It's going to consolidate. It's going to consolidate around actually fairly similar functionality coming from companies like our own. What are the things that we think that we'd love to have that, for example, 10gen have? Well, today we don't have a document model. If you want to store documents, you can, but they're basically blobs, and you're doing primary key lookups and stuff like that. You can do that, and that's fine. But if you're really wanting to do a document model with full document indexing and all that kind of stuff, that's yet to come. That doesn't exist in the product today. Other things, as you heard before, we actually regard the kind of key value store level of the system as more of a storage technology than a database technology. And so we're fine using a wide variety of storage models, and we're happy to use whatever key value stores are available to do that. But if you said, what would I love to have that Couchbase have today? We haven't invested anything like the work that they have at the level of storage. What we tend to do is to use products like those to do that.
Isaac Foster in the audience asked on GoChat, database months GoChat. Isaac Foster, you there?
Yeah.
Oh wow, look at that. Okay, sorry. He basically wanted to know of the databases up here that don't support ACID, essentially how do you replicate it? How do you replicate that eventual consistency on a multi-row transaction? Sacrificing, basically. Well, that's a pretty expensive question, I said.
Yeah, I put that specific example. What I meant, is there like a relaxed ACID? Maybe you might have eventual consistency on a multi-row write, you would have isolation or something. Is there anything you guys have considered doing for that? That would be, a relaxed version of transactions.
So the way I thought it before a little bit was, we think that we can actually do it fully ACID just on certain keys, right? So if you've got 10 collections, you've got a user profile collection and a user accounts collection, there's like one row of one and 1,000 another. You say, look, I want to be able to do transactions across these two collections on this key, and then you can do it, right? We keep all the data in the same shard, no matter where they are geographically, and you can do it. I think doing it relaxed, people fake it with a lot of things, doing a lot of optimistic locking and a lot of things like that. You can basically do little journaling inside of documents. There's a lot of ways you can do it. I think there is definitely a benefit having the database do some of it as well. But people definitely do sort of mini journaling, right? Think about how things like Google Docs work, where you don't keep a current state, you keep a list of edits to get to the current state. You can definitely build on top of something like Mongo, but I'm not sure that's always the right solution.
I don't have much to add to that. I mean, I think, people, I think you had a specific question about ACID, but in general, people throw around ACID and say, okay, how are you going to implement ACID in an NoSQL database? And I think you got to think of it differently, right? In terms of consistency, we're consistent in the sense that, you can read your writes, and, there's one node that stores a document, a particular document, and we replicate it on other nodes. And if you want to guarantee that write is going to be persisted to the local disk, we have a parameter that says you can do that. If you want the added assurance that it's also replicated to one node, two nodes, three nodes, there's a parameter that will allow you to do that so that you get the right level of durability, right? But it's different than a relational database. You got to think about what is the consistency model, right? And then to add to that, if you use cross-data center replication in our product, then it's going to be eventually consistent across the mirrored databases in the two data centers, right? So I think it's a different model, and simply trying to use what everyone thinks of as ACID and then trying to say, how do you implement that on a NoSQL database, I'm not sure is the right way to look at it.
Just jump in and say, I think that what we are saying is that you can have a distributed, fully ACID database in multiple data centers at the same time. I realize that that's novel. I realize that's an innovation that hasn't been available today, but it is the case today, and you can download our product and do it. The issue on transactions, I think, as with the issue of SQL, I think Bob actually said it, which is the whole idea of these things is levels of abstraction. What you're trying to do is to not have developers having to worry about things like consistency, because that's why you've got a database system. And so if it can be done under the layer of abstraction that is the database layer of abstraction, you want to do it that way. Otherwise, you're going to start building what I would think of as parts of the database system inside your application, because you have no choice. And so that would be the view. I think that I honestly believe that we are all probably moving in a direction which is much like what we have in our own product, so that we don't have application developers having to worry about these, what are really database issues.
Okay, let's start moving on towards the modern spectrum of databases and how the future will look. To compete as a modern database in 2013, what do you think the key requirements are to compete in the database landscape our present day?
I'll be going last, so it's only fair for the other guys to go last.
I'm trying to randomize.
No, fair enough. What I'm going to say on this is, I think the key is it's a gigantic landscape. It's a $35, $40 billion market already, and it's growing like crazy. We're moving to a next generation internet, which is going to have 50 billion devices and billions more users, mostly mobile. Your refrigerator, your car, everything else is going to be on the system. And so there's lots and lots of space for lots of people to be successful. And so I think that compete is really about which are that. There's going to be a relatively small number, but there's going to be less than a dozen, let's say, companies that come out of this as the next big players. The last generation was client server. This generation is scale out or commodity or whatever you want to call it. And there are going to be a few companies that win that. What do I think is the most critical thing? Everybody knows the answer. Performance, scalability, followed by reliability, followed by this always on kind of stuff that we talk about.
I agree with all that. Maybe put into a little bit of perspective where we are, at least from a NoSQL perspective. I mean, NoSQL, in terms of having commercial products, is, I guess, 3 or 4 years old now. I'm not sure when 10gen got your first commercial product out. I think it was probably 2009-ish.
Sold over a thing.
So it's a very young industry, it's very young technology, and it's not surprising that there are some people that catalog all the NoSQL solutions. I think they find 40, 50 different companies, open source projects that are out there, and that's typical in the early stages of a technology space that's expected to be very big, and as a result is getting a lot of investment, whether it's money or people's time. But now we're 4 years into it, and you're starting to see a few players pull out from the rest of the pack, which also is not at all surprising, right? And so 10gen is unplayed out from the pack. I think the industry, the NoSQL piece of the database industry is going to be very large. I don't think you're going to have one company that's going to dominate. And like all industries, typically there are 2 to 3 that end up being reasonably large in size. And then other than that, there may be some niche players that are particularly good at something very, very specialized. And that's just how typically industries evolve over time. So that's one perspective. I think the other is that we're pretty close, in my view, to NoSQL really starting to take off in a mammoth way. I mean, it's grown very, very quickly for the last few years, but I think the leaders are filling out the features that are really critical for the broad market, whether it's developing the ecosystem of connectors to various products, whether it's doing things like adding the security features that you need and compliance features that you need. There's a bunch of kind of round out technologies that are really important for this stuff to take off. And some users are a little frustrated because some of those capabilities aren't there today, but wait a quarter, wait a couple of quarters, wait a relatively short period of time. All that stuff is going to be there, and then you're really going to see this stuff take off. Because all of the leaders certainly have tremendous success stories of people using this stuff as key technologies, very strategic technologies that's only going to grow within these companies. So, I'm of course very excited about the industry, and the best days are ahead of us, and the number of people that are using NoSQL now is a tiny fraction of the number of people that are going to be using it and deploying it just a few years from now.
Yeah, so I don't disagree with almost anything said here. I think there's a few things, big picture things. Where one is I think there's going to be a lot of consolidation over the next few years. There has to be. There's a need to be that many products, both on the product side and on the features side. I think there will be a lot of convergence. You were saying, features. A lot of we're looking at adding features. People generally think of relational features, relational databases tend to add features. People think of document features. So a lot of convergence. Clearly, scalability, performance, reliability are paramount. But I think the one thing that is going to be critical going forward also is development productivity and development flexibility. Right? I don't think we've ever seen a period of time where there's been more new languages and frameworks gaining adoption. Right? If you look at Go, popped up a couple years ago, and now it's getting popular. You've got Ruby, probably a million languages out there that people are using a lot. And I don't see that stopping. Right? And while I think there's going to be a lot of consolidation on the database side, I think on the language side and the framework side, you're going to see more innovation. Because I don't think anyone's solved it yet. I think there's a lot of interesting things happening there. And so I think actually the database is going to be a little different, right? A little bit more, it's centric, right? People went a little bit, to the extreme of, you got an app server tier, and you got the sort of 2-tier model, and if you want to talk about the database, like the database is going to once again sort of be the center of the world where you got 10 different languages talking the same data, and that's going to be critical. And having the features that developers need to be able to make sure that works well, and so they can be very productive is going to be incredibly important over the next 10 years.
Okay, I would absolutely endorse everything that's just been said. There's this kind of pervasiveness of languages. There's almost whole kind of communities of people. I also totally agree with the centrality of databases, and I think we probably all agree with this, that we went through this 1990s phase of lots of app server kinds of technologies and so on. I'm seeing quite a lot of kind of disintermediation of that tier, and databases being much more functional and much more central to people's architectures.
In the future, do you think there's going to be a place for traditional SQL database like Oracle and Postgres?
Well, for sure. I mean, we believe strongly relational databases are going to be around, and not just because they've been used in the past, but because they do some things really well. I think there's certainly a technology disruption taking place in the database industry, but I think there's also a business model disruption, and it has to do with open source. We certainly believe strongly that the winners in the database space, both for operational databases as well as for analytic databases, are going to be open source. And we'll go through all the advantages of open source, and it's a whole nother discussion, but I think that's going to happen. And I don't think it's a coincidence that MongoDB, Couchbase, and Cassandra are all open source projects. And part of that is that open source phenomena is associated with how the products are developed, but it's also a phenomenon with how the products are distributed or how they start to spread. Because obviously with open source technology, one of the biggest adoption patterns, of course, is you just download this stuff for free, you play with it on the weekend, you love it, you start using it more and more. And so you mentioned Oracle and I don't think you mentioned IBM, but Oracle, IBM, and Microsoft being the leaders in that space right now. They're proprietary software companies, and I think that is going to be a big issue for them as the industry continues to evolve.
So, I think there's a couple things to think about. One is that the relational model is very good for certain applications. Right? The docket model we think is good for a lot, but there are plenty of use cases where a relational data model is the right thing to do. So I don't think the relational data model is going away at all. I think there's some use cases for that. Whether Oracle or Postgres are around 20 or 30 years from now, probably, I don't know the future. But I think that data model is not going anywhere. The features they have aren't going anywhere. Whether they're replaced by things that do the same thing, it's perfectly possible. But that model's not going away. Those features aren't going away.
Yeah, I have to say, I don't think it's primarily a technology conversation. I mean, with the greatest respect to the enormously good work that's been done over the last 4 years in the NoSQL space, what we have today is a $40 billion SQL database market and a $0 billion NoSQL database market. Not to be funny, but there's a reality there. And if you go back to the precedent for this was mainframes. Now, the mainframe IBM databases did not move onto Oracle as a generalization. What they did was keep running, and they're still running today. Okay? That's what's going to happen. There's a piece of this market that is going to be forever locked into the sort of client-server model that they're in and so on. The interesting piece is the growth piece that we're all focused on. And around that, the interesting question is, what proportion of that is going to be people saying, you know what, I kind of know and love SQL. Not just technically, but I've got lots of people that understand it, and I've got tools, and I've got business processes, and all this sort of stuff. In some sense, we've got a railway network. It's out there. It's called SQL and transactions. And if someone can build a new train, wow, that's what we want. So there could be a proportion of the market that's going to be that. But the question wasn't about SQL or not SQL. It was about specific fails, traditional fails. My view is, now that the problem has been solved about how do you elastically scale SQL, now that that problem has been solved, it's going to, and also solved at a completely different business model with a completely different price point. It's going to be hard to see how those systems keep expanding. And so the likelihood is that those traditional SQL vendors will be in very profitable markets, historical markets, but not actually part of the problem. And I'm going to say one comment on this. When a leading VC, actually was Mark Ingres, was asked about his portfolio companies and how many of them are using Oracle, his answer was 0. I think that kind of gives you the answer.
Okay. Just different sort of angle, similar topic. Traditional databases like Postgres and MySQL are starting to add document APIs to mimic NoSQL functionality, and then you have the reverse where you have NoSQL databases giving SQL interfaces. What do you think we're headed in? NewSQL, NoSQL, or will every database sort of end up being a hybrid solution?
So, I'll start with the relational databases adding document features. So there the problem is, fundamentally the question of, I've got a document, and can a row in a relational database maybe contain the JSON document? When I index that, does the index actually go into the document and does it understand it? And same with updates, same with queries, same with all the rest of those factors. Right? It's one thing to just store JSON and be able to view it, but I think the key factor is whether or not you can actually, the language in the database naturally know how to introspect it and act on it. Whether they add those features or not, I'm not sure about, but I think that's where the key determination, because storing JSON is not novel in itself. It's whether or not you can, look at why people like documents and Mongo, is that they can index an embedded field in an embedded field or modify some part of the document that isn't the top part. And so that's sort of the key feature there. Will they add them? I think it's very likely they'll start adding them over time. I think the question is which way does it evolve better? And then on the other side is, I don't think you're going to see something like Mongo adding SQL anytime soon. I think we view it a little bit differently. we think SQL works really well for relational databases, but if we added sort of a SQL interface to Mongo, in order to do the things people want with documents, you have such a Frankenstein SQL that it really won't look like SQL anymore anyway. You have to rerun it anyway, so you have something totally different, which we think at that point is really not that much value in it anyway. Other people may think differently, but that's what how we do the space.
I agree completely. And to me, this is marketing ware, right? It's like, I want the checkbox. I'm getting hammered by a bunch of customers for some features, or they're telling me about all these reasons why they're going to NoSQL solutions, and the marketing and product marketing people hear that stuff and they say, I need documents, I need to be able to store documents, right? And so they build this capability. It doesn't really deliver what is exciting and interesting about documents, right? And building indexes and queries and things. It's just a check mark on their list of check marks, right? And NoSQL will probably have those too at some point, right? But that's not what it's about, right? What it's about is the fundamental trade-offs that you're making when you're really building at its heart a document database, or when you're really building at its heart a relational databases. And you're not going to change those fundamental trade-offs by just putting a few peripheral things that give you a checkbox on your, on your marketing brochure.
I think this is a great question, actually. I think that there is no doubt that there's been kind of what's sort of a lipstick on a pig effect on some of these things. That people are saying, well, it's kind of what's a document? It's kind of a row, isn't it, or whatever, and they're trying to do that. And so there's definitely some of that going on. It's interesting, though, not at that level of have they done a good job, but it's interesting at the level of, if you already know how to do, storage, transactions, and security, and all these other things, which are model independent, then doesn't it make sense that people should be able to choose their model? And this is probably where I would disagree with some of the things Bob is implying, which is that there's nothing about the relational model, which is only really a kind of a superficial thing in a sense. There's nothing about the relational model that says anything about how it's implemented. Relational database could, and in fact ours is, could be very easily implemented on top of a key value store. And so the traditional ideas, which this part I agree with, the traditional idea is that your schema drives the way that you store the data. That's not going to work in this world. What you need is to have value-based storage that's self-describing and doesn't have anything to do with the schema. You store a relational database. If you're going to build a system that is predicated on really being a sort of a fancy file system, then you're not going to be able to scale in the way that our systems can scale. If you design the relational database in a similar way to the way that Couchbase is designed, so that you can have elastic scalability and so on, and then layer SQL on top of that, you get a completely different answer. So my view is that there will be this consolidation in the industry. I think that people will have ways that they like to access the data, the way particularly store and retrieve the data. I think that people will need data management languages, SQL-like languages, which will be set-based in order to manage that data. And you're starting to see that on the analytics side, where there's much more data management as opposed to just storage and retrieval going on. And so I think there is a convergence that's happening, and it is going to happen. We saw Google came out not so long ago saying, Google, of course, was publicly quite anti-SQL for a long time. Next thing they come out and they say, look at our SQL database. What's going on? What's going on is people are realizing that there's this kind of need for kind of a converged kind of model. And so, yeah, so I think that the answer is all of us are going to be facing these kind of questions over the coming months, because that's where the industry is going.
We have an audience question on GoChat from Long Wong. Long Wong, where are you? Right there. Long Wong is directing the question at Barry. Says, NuoDB sounds fantastic. Will you offer an open source version?
Good question. We have not announced going open source. We love open source, and I've done a lot of open source stuff in the past. The significant parts of the system that are open source today, the core is not open source today. And I'm not going to pre-announce what we may or may not be doing around that. But you should hear that our view on database technology is actually that on all software technology is it's very clear that it's becoming more and more and more open source. And that's not where we are today.
Okay, we have another audience question in GoChat. Seth Rodenberg, where are you? Seth, right there. Seth, we've directed this kind of at Eliot, but it kind of applies to everybody. Where can you learn NoSQL or NewSQL? What resources?
Right, so for MongoDB, the best thing is we've got online training. We do the online training courses, which they're pretty good and they're pretty long. There's also a lot of documentation out there at MongoDB. Our docs are pretty thorough. There's a number of books. And there's a new book coming out, the second edition of the MongoDB definitive guide that's coming out, I think, pretty soon, which should be pretty good. So, and they actually do sell them on Barnes & Noble, so you can actually just go and pick one up if you want. Just kind of interesting to me. And that's probably the best thing to do.
We have similar things. You can go to our website, couchbase.com. There are a number of different things. Obviously, documentation's online, easy to download, easy to install. The weekend you can start, just playing around with it. We have something we call Dev Days, which is a one-day exposure, hands-on exposure to Couchbase, and we do that in lots of cities around the country and around the world. So check out, for a date that's nearby, that's close to you. And then we have our Couchbase conferences, which we do in major cities around the world, certainly including New York. And I don't remember offhand what the date is. That's a full day of mostly customer presentations that talk about their use cases and how they're using Couchbase, and we have a ton of our developers there and have places where you can just go interact with our developers to get help. So those are a few ways that we're trying to expose people to Couchbase.
Yeah, we get to cheat on this, of course, because you already know how to use it. It's SQL. And so, so there's a zillion places out there that you can find out about SQL, including a very large standard if you really want to read that. And JDBC and ODBC and, Ruby Active Record and all the things that are typical SQL things. So it's kind of relatively easy from that point of view. It's a 3-click download and install. Okay, this is not your daddy's relational database. This is a very simple download it, install it, and bam, it's up and running. Things like adding an extra machine is a right-click and add a machine. Okay, there's no partitioning, there's no sharding, just add a machine. So these things are very, very simple, but programming it, it's SQL.
Okay, let's move on and talk about big data a bit. There's a common perception that big data is somehow related to NoSQL. I want your opinions if you think that's accurate, and also if there's a role for SQL in big data in the future or now.
Okay, so big data is the most amorphous term, or one of those amorphous terms that means so many different things. I think most people, when they think of big data, they're really thinking about analytics and taking huge data sets and asking some question of that data and trying to get some insight from it. So if that's what you think about in terms of big data, certainly Couchbase is on the operational database side. That doesn't mean you can't do some analytics, but you wouldn't run, a super complicated, analytical job on Couchbase. Typically, you can do some smaller analytics, and many of our customers do. I think from our perspective, the impact of big data, meaning just the fact that we're collecting huge amounts of data, right, and the amount of data that we're collecting is growing exponentially. So that's one aspect of big data that certainly affects operational databases. The other is that most of that new data is unstructured and semi-structured data that we think fits much better into a document database type model. So that impacts it. And the third, I would say, is just that more and more applications are data-centric. Right? If you aren't leveraging, an increasing amount of data, whether it's a social graph or data that your mobile devices may be collecting or whatever, if you're not looking at how you can leverage more and more data and more varieties of data, you're probably going to be at a competitive disadvantage. And so that, the ease of development that Eliot talked about in terms of this, a better, match in terms of the data model with the applications that you're writing, we think is increasingly important to application developers, right? So maybe 15 years ago, having that super easy, development interface with the database wasn't as important. But today, data is so critical to your application applications that is just increasingly important. So that's some of the ways I think big data affects operational database.
I love the word leverage. I think big data is very simple in a sense. It's all about data-driven decision-making, period. And I think that it's unfortunately named for that reason, because it's really about data-driven decision-making. I do like the 3 V's. I think people talk about volume and velocity and variety, of which the most important is velocity. Okay? The size of data sets there are some giant data sets out there, and you can run big batch analytics in all sorts of ways and get some really useful predictive analytics out of that. That's great. But a lot more value is going to be got out of what you might call operational analytics or something like that, more real time, and it's going to be running in operational databases like our systems. And people are going to be optimizing their operations, reacting to events, and so on in these kinds of systems. So I do make a big distinction between batch analytics, which has its place and it's predictive and all sorts of good things out of that, and where big data is going to be going over the next so many years, which I think is going to be much more real time. What I will say is, when you look at those people that are not just storing and retrieving data, okay, that have, if you like, a broader view of what a database is, and those people mostly are in the analytics world, not only. What are they moving towards? Set-based query languages and data manipulation languages, notably SQL. Why? Because the moment your problem is not just how do I put it on a disk and how do I get it back, you're suddenly into a language problem. And now you're into, you start reading up on cloud and you start going, this is very interesting, really. Why don't I have sets? Why don't I have the ability to look at these sets, update these sets, select them, join them, merge them, and so on. And so I do think that on the big data side, our systems are going to be increasingly used, and I think today are being used for operational analytics. But a lot of that stuff is going to be SQL driven.
Could I ask? Sorry. Ask a real life question.
We're going to do QA in about 4 minutes. Hang on.
So I think big data is a state of mind. It's really just a matter of, do you treat your data as long-term and intrinsic information, or do you treat it as throwaway? So most of the agreement that everyone said. I think actually doing interesting analytics in real time is going to be increasingly important, and that's what really seeing big data sets and do things in real time. I do disagree that it's doing mostly SQL. I think, if you look at Mongo, you look at sort of what we're doing with sort of our aggregation framework, which is really about real-time analytics and being able to do real-time processing. What we're seeing is that, it is a language problem, truly a language problem, because it's not just key value, it's not just, I got to do a query and the data back out. It's like, I've got all this data, and I can analyze it in some interesting way, and I can do aggregations on it, and I can sort it, and combine different data sets and do interesting things with it. Definitely a language problem. And I think the fundamental question is SQL the right language to do that in? And what is the right language to do that? There are new things, there's general. We're sort of doing our own things with the aggregation framework, in some ways building our own language in there. So I'm definitely not convinced that SQL is the right way to do sort of real-time analytics, but I think real-time analytics are definitely going to be incredibly important in the next few years. And what we see in our users is, when the aggregation framework came out last year, incredible excitement about it. People jumping all over it, asking for tons of features, a lot of features that are typically language features. So I think it's going to be an incredibly interesting area to look at over the next few years.
Okay, if I could just ask for each of you some final thoughts, including key takeaways.
First of all, fantastic to be here with these guys that have clearly made a huge success of these kind of NoSQL technologies. And the takeaway on what we're all about is we have what is in effect a SQL technology, except it's SQL. And so all the things that you're used to with NoSQL technologies, which is about scalability, we do that better than many NoSQL databases. If your concern is about sort of schema flexibility and all those sorts of things, we do that as well as anyone. If your issues are about developer productivity or usability, we do that very well. If your issues are really about always on and so on, we do that. And we do some other great things, which is true transactional behavior, true consistency in multiple data centers, and so forth. My comment on the going forward stuff is I think it's going to be a fascinating time over the next so many months. It's probably 18 months or 24 months, in which you're going to see the leaders stepping up and defining this next generation of database systems. They're very different from the last generation of database systems, at last, by the way. But I do think that one of the trends that you're seeing, and it's becoming more and more pervasive, is that it's not about NoSQL versus SQL. It's actually about
databases. And many of those databases are going to be SQL databases or support SQL.
I guess my final message would be, if you don't already know a lot about NoSQL, learn about it. I think it's going to be more and more a part of your world. Maybe not every one of you is going to have a use case where NoSQL makes sense, but I think for most of you, it's likely that over the next 1 to 5 years, you're going to be developing, if you're an application developer, you're going to be developing an application where it makes sense to look at NoSQL. And whether you look at Couchbase or MongoDB or one of the other technologies, I just encourage you, check it out, understand where it can be best used. And if you don't, I think increasingly you'll be at a competitive disadvantage if it is a better technology for your use case. And I think you're seeing more and more very big companies that maybe were skeptical a year ago or 2 years ago that are making major commitments to NoSQL technologies. And I think you're going to see that in a bigger and bigger way.
So the NoSQL space, sort of the NewSQL space is still quite young. And I think, as exciting the last 5 years has been, if you look at Mongo, it's grown tremendously in the last 5 years. I think the next 5 years are going to be even more interesting. But if you look at sort of the Mongo, I know the Mongo roadmap pretty well. If you look at the roadmap for the next 5 years, it's quite interesting. And I think what you see now in 5 years is going to be quite impressive. And I think that's true of a lot of the NoSQL and the new databases. And so I think what the key for me is everything's going to be changing very quickly. So stay tuned.
Okay, before we move on to the Q&A, I just want to give a great big thank you to our panelists. Just before we start our QA, I also want to mention there are t-shirts here. At the end of the QA, please everybody come up and grab a shirt before you go. And start firing some questions. Yes?
Sorry, first. Online, based on serving, I'm doing financial analytics. I have a quant background. So I want to challenge the panel. So especially Barry, since you come from StreamBase, which is complex domain processing. People familiar with financial knows about that. So the thing is, thinking about big data, NoSQL, and even processing. I mean, in financial world, people start doing pick-by-pick database about 20 years. I mean, that's huge amount of data, but highly structured. So what I'm going to ask the panel, starting from Barry, is, they are pushing low latency. We're talking about velocity. Those high-frequency traders, they're talking about microseconds. So what I'm going to ask the panel is this. So what kind of do you see there is a possibility to combine experience from financial world, especially high-frequency database, high-frequency trading, with the NoSQL world, which is totally coming from unstructured data? And if the answer is yes, and how? And obviously there's, I have other questions. I want to focus on this first.
Okay, to repeat his question, basically, is there room in the NoSQL world for financial transactions of extreme performance?
Actually, not particularly from NoSQL world. What I'm saying from NoSQL and those kind of even specialized SQL, column-based binary storage, like in the KDB, like in one tape space. Where do you see from here? Highly transactional, highly non-transactional, microsecond, and web logs.
Right.
So, thank you. You mentioned a previous company of mine which I started with, like Stonebraker, who, aside from Jim Starkey, is the other big name in databases. And it was called StreamBase. It's called StreamBase. StreamBase is a really good pioneer of complex event processing. And so this is a system that does queries on real-time data at the levels of millions of messages per second, and doing what are in effect SQL queries on firehoses of data coming through the wall. It's used a lot in financial trading systems. It's used a lot in intelligence systems and big streams and things like that. The StreamBase data model happens to be a SQL-like data model. It doesn't have to be, but that's kind of how it was designed because that's what the data looks like in financial services. I think a question about how that integrates with storage style databases, because StreamBase is primarily about storage, is a very interesting one and one we spend a lot of time on. And the issues there are actually quite broad, because some of the workloads are in essence analytics-like. And so what you want them to do is to say something like, show me all the examples of the IBM stock price going up by more than 10% in less than 5 minutes, and at the same time Intel doesn't change. It's that kind of a query you're trying to run over the last 10 years or 20 years of stock market data, and then you're wanting to apply that to something that's coming through the wall. Very hard kind of a problem to solve. It works very well when you've got very, very efficient both storage models and also aggregation models. And so typically that was handled actually with a combination of StreamBase and Vertica was one of the examples, and so on. I will tell you what I think, and then I'll also pass it to you guys, what I think about this next generation of systems. Totally agree with Bob about something, which is that caches are a really bad idea, along with sharding and along with replication. Really bad idea. We do those things because we don't know what else to do. And what you want is to have a database system that is in effect an in-memory database system. And so one way of looking at what we're doing is that it's a distributed in-memory system that happens to be logging its data to the disk in a transactional fashion. Those kinds of systems have very, very low latency, okay? And particularly can have very low latency in the presence of lots of concurrency. And very appropriate for the kinds of applications that you're talking about. But I am much less interested in the interface to that than the underlying technology that supports it. We have one customer, for example, right now that's saying, love your stuff, but I think I know how it works, and can we write our own personality and just bypass all the SQL engines and so on? The answer is yes. And that may be, in the long run, because highly specialized applications, including financial trading applications, the way to go. Just bypass, don't use documents, don't use SQL, just get straight into the data and get your transactional systems.
VoltDB, I mean, since you mentioned Stonebraker, VoltDB could solve all these problems that he's talking about, and in fact, there's a paper that you could extract the data out of HDFS and plug directly into VoltDB, and solve exactly the problem. There is a white paper on this that solves this very problem.
Very, very clear with Vault. When we're still called Horizontica, we nearly integrated it into StreamBase. So I know exactly what it is, and it is very good at highly specialized, well understood kinds of problems.
That's exactly what it does. What he's asking about, I mean, Goldman Sachs and Merrill, they already used it to solve this very problem.
Okay, let's keep the floor going. Just next question.
I think it was mentioned earlier that one of the things that the maturing process of new age databases is around security. Okay? Perhaps because of Jim's background, that stuff's baked in absolutely to our system from day one. And so we have a multi-layer security model. All communications are encrypted. There's lots of different ways. In order to be part of a database, you have to have the right credentials. In order to join into the group of machines that have the potential to run the database, you have to have credentials. It's very strong security. It has to be because, remember, we're talking about a system where you could say, you could have a database running on your laptop and say, now I had a node on AWS, and we'll do it, and it'll work. But now you've got a node sitting on AWS with all sorts of man-in-the-middle attacks possible, and so on. And so you have to have a very strong security model, stronger than a traditional monolithic database, because you can't lock up these systems.
Yeah, I think security is a pretty big deal. We're doing a lot of work on, especially around integration with enterprise security systems. That's where you need to do a lot of work into the integrating these turbo systems and auditing systems. Things like IBM Guardian, where you need to audit. You need an audit log for every single thing that happens in the database. And so we're doing a lot of work in those arenas.
security is going to be the next big wave of lots of features that you're going to see from all the NoSQL players. And I don't think to date it has been, you go and look at all the products and say, wow, all the products across the industry are super strong in security. I think it's the next wave. As more and more enterprises, as we have more and more enterprise customers, we get asked much more often about all the security features now than 6 or 9 months ago, and obviously that's going to drive the addition of lots of additional features. Okay,
that's all the time we have for today, but Bob, Barry, and Eliot are going to be here for one-on-one questions right now, so please everybody, in one minute, come up, grab a t-shirt, talk to them whatever you want. Great big round of applause. Thank you very much.